Well, good day. Welcome again. In continuation of the workshop, this is before. Yesterday, we had network challenges, so we couldn't proceed. We are optimistic that today the network will be friendly with us, so we're able to do some other things. Day two, we're able to present to you a regression model, but the regression model was filled with an outliners, hence it could not perform better. But yesterday we improved on the model. After improving on the model, by taking away the outliners, we built the regression model, and because of time, I'll just be fast. I'll take you down to this last set of the two. Find out that the mean square error is 5,942. That is the value. But in our day two model that was built with outliners, I will find out that the mean square error actually gave us 20,201. So you see the difference. So it is always good for you to build your model without outliners. Take out the outliners, take out the null values, take out those values that are not compatible with data type, that the data type has been wrongly assigned. Take them away, take away the duplicates, then build your model, and you see your model will perform better. It will be very okay. So day three, yesterday we looked at the logistic regression, where we used an example, the material from our mentor global AI hub. We used it, and we found out that we built two models. Yesterday using using logistic regression. And the first model, the accuracy was 100, as it actually predicted the classes well. But in the second model, this is actually the first model, and this is the confusion matrix of the first model. With the score 1.0, which means it is 100%. But the second model, we have to change the solver. And yesterday, we are at the point where I showed you the documentation that there are different solvers for logistic regression. You have the Newton GCD, the LBFS. The default is LBFGS. And this was what was used in the first logistic model that we built yesterday, and that gave us the score of 1.0, or the accuracy of 100%. Now, when we change the solver, we find out that our accuracy dropped. Our accuracy dropped to 0.8, which is 80%. And we find out that it's wrongly predicted two values were wrongly predicted in the class they did not belong to. Please, if you want the files the notebook of what we've used so far from day 1, 2, 3, 4, and even that of tomorrow, you can just comment it in the comment section that you need the workbook, the file, and you drop your email address. We'll send it directly to your email address. Okay, so we'll proceed. Today we'll be looking at we'll continue from where we stopped yesterday by looking at an example. This example, we're using a default data set which came together with scikit-learn, because in scikit-learn you have some data set like the breast cancer, the California housing estate. You also have the iris data set, that is the iris flower data set. Okay, there we loaded the data. We imported the packages and loaded the data, which is the X and Y. We are trying to take this data. This is the way you load the default data set. It's different from when you have your data set not using the one that came with scikit-learn. So the other part, I'll show you how you can load that, and we'll conclude today by building some other models. Okay, so after loading the data set, we find out that this is our data set. Look at the information we got concerning the data set. It tells you all the information. You see the columns are very large, and one thing you should observe here is that everything is numeric. Yeah, I do emphasize a lot that when you are building your model, please build the model with numeric values. Okay, and you see this data, it is clean. It is clean. We don't have null values. And also we are going to look deep into the model. This is the describe. These are just EDAs. We use this .sum to know if the model has any null value. That is df. If the data frame, df.isNA, that is null .sum. So if there are some null values